This is 8.7, and we're going to be transforming the graphs of various functions. So the functions are y equals x squared, y equals the square root of x, y equals the absolute value of x, and y equals x to the third. So an x squared graph is a parabola, and its vertex is at the center. And then if I plug 1 in for x, what does y equal? 1 squared would be 1. And what if I plugged in 2? 2 squared would be 4. And then if I plug in negative 1, uh-oh, he's on his phone. Are they good looking? No, that's not worth it. So negative 1 times negative 1 is 1. And negative 2 times negative 2 is 4. This is what the graph looks like. Okay. Now let's graph the square root of x. So it also starts at the vertex. And if I plug in 1, the square root of 1 is 1. So 1 comma 1. And then if I plug in 2, I don't get a very nice number. The square root of 2 is like 1.414. So I'm not going to graph that one. 3 also doesn't work very easily. Square root of 3 is not a nice number. But the square root of 4 is 2. So the square root of 4 would be 2. And then if I try to plug in negative numbers, I get imaginary answers. The square root of negative 1 is I. And I can't graph I on a real number graph. So this graph just looks like that. And it turns out the shape of that graph is exactly the same as the shape of the x squared graph. So it's sort of like a sideways parabola, but it's only half of it. And it's not just similar, it's exactly the same shape. It's just on its side and half of it. All right, let's graph the square root of x. This has a vertex at 0. Plug in 0, you get 0. So in the absolute value of x, what is the absolute value of 1? Wants to know how far away from 0 is the number 1. 1. So 1 comma 1. What about 2? The absolute value of 2 is 2. What about negative 1? So the absolute value of negative 1, how far is negative 1 from 0? 1. What about negative 2? It's 2. And we get this, wow, that was bad. We get this V shape. That is the absolute value of x. Okay, last one. X cubed. Plug in 0, you get 0. Plug in 1. 1 times 1 times 1 is just 1. Plug in 2. 2 times 2 is 4. Times 2 is 8. And then negative 1. Negative 1 times negative 1 is 1. Times negative 1 is negative 1. So this one is going to land there. And then negative 2 times negative 2 is 4. And 4 times negative 2 is negative 8. So this graph looks like this. And it's sort of like a parabola. So you can kind of see the shape of the parabola. This piece has just been folded across the x-axis. And it does sort of have the shape of a parabola, but it's not a parabola. A parabola has a lot of geometric qualities that are very, very specific. And an x to the third graph is sort of a really tall parabola. It doesn't quite fit the same shape as a parabola. So all of these are parent functions. And we're going to take those parent functions and we're going to alter them in some way so that they land in a different spot and look a little bit differently. So if this function was called f of x, okay, so if f of x was, say, x squared, then what would f of x minus 3 look like? So that says, in place of x, I want you to write x minus 3. So the original function looks like this. And where the x is, I'm going to write x minus 3. Because that 3 is hitting the x, it's going to affect the x-axis. And it turns out that everything that affects the x-axis in a function transformation works backwards. So you would think that x minus 3 is going to shift the graph left 3. But the x's work backwards and it would actually go right 3. So this would shift right 3. So if I take this original graph and I bump it over 1, 2, 3 units, and then I redraw all of those points, that's what it would look like. Okay? If this graph was g of x, and I said, what is g of x minus 3? That would just be the square root of x minus 3, and that's going to shift the graph over 3, and it would look like that. So anything on the inside affects the x-axis. Okay? Let's call this graph h of x. So h of x is the absolute value of x. What would h of x plus 2 be? So that just says, write down the function h of x. So that function is the square root of x. And then add 2 to the outside. What do you think that's going to do? Whoa. That was no good. We'll get back in there in a minute. So what do you think the absolute value of x plus 2? Well, is that 2 on the inside of the function or on the outside? It's on the outside, and the inside affects the x-axis, so the outside must affect the y-axis. And the y-axis works in the direction you think it should. So it should just shift the graph up 2. We'll take this original equation, original graph, we're going to bump it up 2, and it would look like that. Now it is possible to do both transformations. So let's say this is j of x, x to the third. It is possible to have j of x plus 1 minus 2. So that would be an x plus 1 on the inside and a minus 2 on the outside. So the inside is going to shift left 1. So we'll go this way to there. That's the x plus 1. And then the minus 2 should be down 2. So that is my vertex. And then the graph has the same shape. Does it matter which one of those I do first? Is left 1 down 2 any different than down 2 left 1? No, it's the same. Now, there are some cases where it does matter. So it's always a good idea to follow the proper order. And the order is start in the middle and work your way out. So technically, we should do the left first and the down second. But in this case, it's not going to matter. All right. So what if I had 2 f of x. Let's say that my f of x was the absolute value of x. So 2f of x would be 2 times the absolute value of x. That 2 is on the outside, which means it will affect the y values. And if you double the y values, the graph is going to be taller. So the original absolute value graph looks like this. So this point is negative 1, 1. This point is negative 2, 2. And it says double the y's. So negative 1, 1 becomes negative 1, 2. And negative 2, 2 becomes negative 2, 4. You might look at that and say, oh, the graph got skinnier. But did we actually move the x's? Skinny would be an x movement. So while it does look skinnier, the actual movement was taller. What if it was 1/2 x? 1/2 the absolute value of x. Then it's going to be shorter. So we take this y value and we cut it in half. We take this y value and we cut it in half. And now my graph is shorter. Okay. The only other thing would be, what about negative g of x? So let's say g of x was the square root of x. So negative g of x is going to be the opposite of the square root of x. That negative is on the outside, and because the negative is on the outside, it's going to affect the y values. If I change the sign of every y value, so my original graph looks like this. This point here is 1, 1. If I change the sign of the y, it's going to just flip upside down. Okay, let me get Alex back on board. All right. So the original graph was, here we go. The original parabola is 0, 0, over 1, up 1, and then over 2, up 4. And this wants us to double the y values. So instead of over 1, up 1, I'm going to go over 1, up 2. And then over 2, up 4 turns into over 2, up 8. And that's my new parabola. Okay. So this one is 3 times taller, upside down, and up 6. So my vertex is at negative 6. Normally I would go over 1, up 1, but this is going to be twice as tall and upside down. So over 1, down 2, over 1, down 2, and then over 2, up 4 turns into over 2, down 8. Can you remember that? All right. So plus 1 on the inside means we go left 1. And plus 2 on the outside means we go up 2. So that would be the location of the new parabola. All right. So this translation would be left 3. Look like that. This translation would be down 2. So it would look like that. Okay. This one has a -2 on the inside, which would be right 2, so to there. And a -4 on the outside, which would be down 4. So that would be the new location. We've done lots of those. Okay. So this one's a little bit different. We start with this function. So negative x squared plus 1 is the original function. How do we move that graph down 7? Well, we put a -7 on the outside, and then we simplify. So negative x squared minus 6 is this graph shifted down 7 units. All right, what's happening here? This is going to move it right 4, so to there. This is going to make it half as tall. So if that is the original graph, then the new graph is going to be half as tall. And then the negative is going to flip it upside down. And let me show you. I gotta go to my computer to show you how to do this. So I want to change its height. So I change this from 1 to 1/2. And then I flip it upside down. And then I'm going to move it over 4. Guess I did that in the wrong order. You should move it, shrink it, and then flip it. Okay, so here is the original graph, the negative square root of x. So what is g of, well, so we moved left 2, so it's going to be g of x plus 2, and we moved down 4, so we would subtract 4 on the outside. So the original f of x was negative square root of x. So I'm going to take that negative square root of x, and I'm going to stick these transformations in there. So x plus 2 goes inside, and -4 goes on the outside. That's it. This is the last module in this section. So our next assignment will be the practice test. So a couple of you are a little bit behind. Let's get caught up today.